Hello, hello?
Right. I get to steal your time. So why don't we start? People will keep coming in, but hey. Isabelle's now at Google, but I knew her when we were all at Bell Labs. And that was a long time ago, yeah. But I think we're kind of similar age, no? All right. You think I'm older? Maybe. All right. Never ask. Okay. You were a postdoc when I was actually a real person. Okay. All right. Anyway, Isabelle was in this amazing group in Homedale at Bell Labs. Homedale is really, really far from where I was in Murray Hill. AT&T had a building on every exit of every highway in New Jersey, and you could go from any building to any building in half an hour, with the exception of Homedale, which was an hour. And that was the end of the world as far as we were concerned. Anyway, this group in Homedale, so I was in the group that was right next to the guys who invented Unix, and that we thought was the center of the universe. But Isabelle really was in the center of the universe. And this was like Larry Jackel's group, which they had sort of two things you may have heard of some then. Things like support vector machines, and then you probably heard of deep nets. I'll ask her to maybe explain what the connection was. I think there was a big struggle between the two, actually, which is probably not well known these days. And then in the early days, the SVMs worked better. And nowadays, nobody can remember what SVMs are. Is that a fair description? Or I'll let her tell me how I got it completely wrong.
Thank you very much for the introduction. I won't get into polemics. But yeah, it's true. When I came as a postdoc, my department head, Larry Jekyll, forbid me to work on kernel methods, which I was working on for my PhD. He said, I don't want controversies or disputes in that group, so you're going to work on neural networks. So I had to start, working on neural networks and convolutional neural networks that Jan LeCun had brought to the team. And then in secret, I was working on kernel methods and did in secret, the support vector machine paper. Oh yeah, that's even more polemic, So let's get down to the talk. In the corridors, I can, explain all the various, French, I would say, competitive attitudes and so on. Anyways, so today I'd like to, thank enormously Ken for inviting me with, this illustrious audience here. I'm not at all an expert in language models. I made a very brief. I got very briefly acquainted with it. Actually, when I was at Bell Labs, I consulted, with Ken and some of my other colleagues in Murray Hill because I wanted to make a post-processor for a handwriting recognizer I was working on. And after that, I stopped working on handwriting recognition. I worked, on biomedical applications, then computer vision, various other things. And then just like a few months ago, when I joined Google, I thought, maybe it's time now for me to learn a little bit about language models again. And that was, a month or two before ChatGPT came out. And then since then, the story. So I got, really carried into a big storm. And over the past maybe decade and a half, I've done the organization of challenges in machine learning. I started a nonprofit, and we have like maybe 2-3 challenges a year. And this is my way of learning about new things and also encouraging young people to address new hard problems. And because while I was raising my kids, I worked from home and I didn't have a big research lab. This was also my way of directing research and having people from all around the world work on problems that I thought were interesting. So I became kind of a professional challenge organizer. And when I got at Google, I didn't really know how to get, to have project take off the ground. I didn't have anybody who reported to me yet. And I thought, oh, okay, I'm going to try to organize a challenge on large language model problems as a way of learning about these new technologies. And so this is the result of that work, which I did with two master students whose names are complicated. Tongjia Hugh Kwong and Benedictus Kent Rashmat. And the title is Auto Survey Challenge. So what is it? So what our goals are is to evaluate the state of the art in automated generation of survey papers. So we sort of starting small, and not trying to revolutionize science immediately, even though we have in mind, this is how the whole thing started. I heard about Galactica, and there was all this fear, that we would be flooded by fake scientific papers. And I'm thought to myself, if we are that close in the state of the art to be able to create papers that are undistinguishable from real scientific papers, maybe we can do something useful with that. And so, obviously, it's going to be tremendously hard to create good scientific papers, but maybe we're not that far from creating good survey papers. So we set to work on that. And the secondary goals are to expose the AutoML community. AutoML stands for Automated Machine Learning, and the data-centric communities to large language models, because this is a little bit now, separate bins. And to obtain also better AI reviewers, because we very rapidly realized that if we wanted to get into that realm of creating papers, we're going to need to have also reviewers. And the human reviewers are already completely overloaded, so we're going to need to have AI reviewers. And if we actually have AI reviewers, well, they may be good at reviewing artificial papers, but they may be also useful to review actual human papers. So I know this is a big controversy, and there is a fear right now that people will be using language models to do reviews without disclosing that they are doing so. But at the same time, talking to the program chairs of conferences, they welcome very much having tools to be able to verify the quality of the reviews and also alleviate some of the work of the reviewers that's more mechanical, like, for example, checking that references are correct, something that you've been working here on. And so we would like also to eventually bootstrap a series of competitions on this theme of creating papers and evaluating them. So in the end, although we started from the idea of generating paper, more and more we got into this evaluation problem and realized that the evaluation may be as important or more important than the generation. So we might have our second round of challenge focusing more on the evaluation part. So for example, we generate a benchmark that generates paper using a particular workflow with many different language models, and then the participants would have to create reviewers, and obviously then we'd have to evaluate the reviewers with meta-reviewers. So I'll tell you more about this story. All right, so it's maybe a long introduction, but I wanted to make sure you understand our motivations. So now, our principal objective, or our original objective, was to crowdsource the problem of creating an AI author. So the input to the AI author is a scientific question, or what we call a prompt, and then the output is going to be a scientific paper. So as I said, we want to limit ourselves for the moment to survey papers. And in this challenge, we also simplified things to the extent that we limit ourselves to 2,000 word surveys, including the citations. And we want it to be a code submission challenge, so people have to submit, an automated agent. But That agent is going to have access to the internet, so can, in turn, call search engines, can call if it wants large language models via an API. Everything's permitted because we would like, to evaluate the state of the art. So you are allowed to use third-party tools, even remotely. We don't provide any training data, so it's a test-only challenge. It's kind of a regression, compared to the advances we did previously in the organization of challenges. Over the years, we got more and more sophisticated in terms of running on the challenge platform the code of the participants and doing both the training and the testing on the platform so that everything's reproducible. But unfortunately, with the rapid advances of foundational models, the models are becoming so big and so complex that the computational cost of running the solutions of the participants, both at training and test time, is beyond what we can afford, both in time and in monetary cost. So we kind of went backwards in time and said, okay, we're going to run a test-only challenge. People have to submit their code, but it's going to be trained models or a code that accesses trained models via an API, like accesses a web service, for example. Right. So the most prominent problem we had to face is to evaluate the papers. So we very rapidly figured out we needed to implement AI reviewers. And then we thought, okay, why not, also ask the participants to contribute AI reviewers? Because the kind of forward-looking thought is that we would want to implement a peer-reviewed journal of AI agent. It's actually, an idea I've put forward. I've actually tried to convince people to become editors of a peer-reviewed journal of AI agents, but everybody's very busy and everybody tells me, oh yeah, that's a great idea. And I tell them, do you want to become an editor? Oh, maybe later. I don't really have time right now. I'm too busy. So, okay, I thought we'd do something a little bit smaller scope. We do this challenge and people are going to volunteer to review 100, papers also, and then we'll take it from there. But nevertheless, I think it would be a good tool to have a peer-reviewed journal of AI agent to make the whole field progress so that, people can contribute, AI authors and AI reviewers, and they, work with one another to improve the quality of papers, and then the humans only arrived in the outer loop. The humans are the editors, and they're there to accept or reject papers. And in doing that, they provide feedback both to the authors and to the reviewers, very much like, in any journal, in any peer-reviewed journal. And because, when we do science, we've seen that this kind of system works to make science progress. Why wouldn't it work, to make AI progress, to become better and better at solving problems? And also, you can think of the humans as, editors proposing call for papers or program managers. If you think that what is being produced is not necessarily a paper, but it could be a proposal in response to a program from a government agency. So you can think of the humans maybe also as program managers proposing directions of research and making the whole field advance in this way. So we have an inner loop in a way that where the AI systems work with one another, and an outer loop with the human feedback. So that's the kind of long-term big picture. So now what did we actually do? It's slightly simpler than that for the moment. So in this challenge design, I'm going to talk to you about the role of the participants and the organizers, the organization of the challenge in 2 phases and tracks, the automated evaluation during the 2 first phases that we call feedback and development phase, and the final evaluation by a human jury. And this little cute robot guy represents our AI, what we call referee reviewer. So it's our own implementation of an AI reviewer. And by the way, all the pictures here have been generated by AI, mostly by the Imagen software and sometimes by DALL-E. So first, the role of the participants. The role of the participants is to submit AI agents that can be both authors and reviewers, and they must submit code that follows a well-defined API. The code is executed on a challenge platform with access to the internet, and no training data are provided. So I already mentioned some of that. One aspect of it is that it's kind of a lot of work to design both an AI author and an AI reviewer. So we let the participants free to work only on one of the two aspects and use our baseline methods to replace the other one if they want to. Other questions at this stage? By the way, don't hesitate to interrupt me at any time.
I might have a quick question or comment. It reminds me a little bit of like adversary training. Is it like how you see the loop, or is it like substantially different?
Yes, that's a good point. I also asked to myself, is it adversarial or not? The reviewer can be thought of as an adversary, but in the scientific community, do you think the reviewers as adversaries? Sometimes you do, sometimes you don't, right? So they're supposed to be helping you getting better and better. So not really adversaries, but I agree with you that it has a flavor of that. And I was mentioning before that in the future we might go towards a challenge on evaluation. So it's extremely critical now for companies like Google or other companies that are commercializing large language models to put them to very hard stress tests, and indeed the evaluators have to be like adversarial, like they want to play the role of the bad guys who will try to shame the companies for outputting language models that either fail and give inaccurate answers, or use inappropriate language, or on and on and on, right? So this is interesting, because one of the aspects that we implemented in our own AI reviewer is to filter for offensive language. But this is very rare, that in a paper people use offensive language. But you nevertheless want to have a critic or a module that checks for that, because if you have some adversary that wants to shame you and submits a really offensive paper, you want to filter that. And if you look at the guidelines for most journals, they tell you that if you're an editor, for example, of a special issue, as the editor, you're responsible for making sure that there is no paper that uses offensive language or makes libelous statements and so on. So it's specifically addressing that. So I agree with you, there is a thin line. Yeah.
So in the offensive language camp, you made a reference to how your former boss, Larry Jackal, wanted to harmony. I don't think you would have seen that any of those warring camps would use language that would get dinged by the censors we're talking about, but it was definitely caused disharmony. I'm thinking of, there was a debate between Herb Simon and Mandelbrot over Zipf's law, and the editor of the journal allowed each of them to have one last shot at each other. Anyway, I can imagine that what counts as offensive in the scientific literature might be very tricky for these very different. Anyway, I had a different point here I wanted to make, which is when you're talking about a paper, what's a paper? So I could think of the AI, this challenge being more or less successful on, say, survey papers, tutorials, textbooks. Those things maybe you got a shot at. The thing I think would be really hard would be original contribution. And so maybe it'd be worth trying to separate the different tasks in some way.
Yeah, totally. So really in this particular challenge, we are focusing strictly on survey papers. But I'm interacting with many colleagues, at Google that are more interested in optimizing entire scientific workflows, and they really want to generate scientific papers. So I think the next step will be to generate scientific papers from already collected data, so kind of observational studies, and let the agents search for relevant data on the internet. Maybe an even kind of intermediate step would be to run meta studies. So often in the medical literature, you have these special kind of studies that are called overview and meta studies. So these are very codified, so we can just basically follow the blueprint for meta studies. Then, more general observational study than meta studies. So studies that haven't been done yet, but that are using already collected data. And of course, the last step will be, to have the language model design experiments and conduct studies. But this poses, I probably imagine, lots of different issues, including ethical issues.
I think kind of hopping off the question of if you're expecting novelty in these papers, but also like how complex are these scientific questions? And like, are you asking questions in the hope that they would generate novelty, or is the reviewer more aiming for grammatical correctness, like factual correctness, and like the quality of the writing itself?
Yeah, we're gonna see what the review criteria are in just a minute, but this is a very good point. I think novelty is not stressed so much in survey papers, although you could say that there can be elements of novelty in survey paper if there are already previously published surveys on the same topic. But we at this stage we are this is very preliminary. You have to see that this is the work of 2 first-year master students for 3 months, so you can't expect too much yet.
One more question.
Sorry, I'll try to make it quick. So if you were to eventually get this objective to work and that gray box turns into more like a black box, wouldn't it then kind of push all of the work to prompt engineering? Meaning we would no longer have to think about doing that stuff, so we just become really good prompt engineers?
Totally. In fact, it took a little bit of effort to explain that. I'm glad you're raising that, because a lot of people who went to the challenge didn't know what the challenge was about, didn't know where they should put their efforts into. And I think one easy way of entering the challenge is just working on prompt engineering at this stage. But, why not? There have been challenges in classification and regression for many years in which the name of the game was feature engineering, right? And many people won by feature engineering. They all were using random forest and XGBoost, and they won with feature engineering. It's not very glorious, but at this stage, I think it's the name of the game. It doesn't prevent you, of course, to do much more sophisticated things, right? All right, so we went over the role of the participants, the role of the organizers. So we want to provide good prompts, and we also will need ground truth from the prompts. So that's an interesting aspect. I don't want to go too much over time, so I'll have to gloss over this, but I was under the impression that we could do these reviews without ground truth. And why would this be important? You see, right now, most of the language models are being evaluated with queries and answers. And most of the time, you have the right answer for a given query, or you have a couple of right answers, but we don't have open answers. Evaluating language models with open answers is very difficult. And this was my hope that the reviewers we were going to design would be capable of evaluating answers for which we don't know the right answer, or we don't even know whether there is a right or a wrong answer. But as it turns out, as we kept working, we nevertheless felt the need to calibrate the reviews, and we are using ground truth for what we think are good or bad survey papers, and I'll explain how we generated those. Then we also need, as organizers, to provide means of evaluating the submissions, and this is, what we call the AI referee reviewer, the little green guy. And we quickly realized that in order to evaluate reviewers, we needed a meta reviewer. And finally, we have the human evaluators. So the challenge is organized into 3 phases. We have first a feedback phase, which is very short, where we put out, the starting kit and some sample data and ask people to give us feedback about the protocol to verify that we didn't make big mistakes and that things are understandable. This feedback phase ran, last week before we did the official opening this week, because I wanted it to be ready for you guys. And now we're entering the development phase, and you're welcome to join and have fun for 4 weeks. You can make up to 100 submissions. And I'm sure in this crowd, there are people who are highly capable of winning. So the prizes are not very big, but you could have the fame, of winning a challenge which is among the official selection of the Automated Machine Learning Conference. Plus, if you enter, then very likely we're going to have a sequel challenge. We ambition to submit a proposal to the NeurIPS 2024 conference for a NeurIPS challenge next year, which is going to be very exciting. And if you participate in this year's version, then you'll be well prepared to win the next one. So keep posted. And that, I have to tell you that, at NeurIPS right now, we're having a very strong data sets and benchmark track, and you can publish into that track if you participate to challenges. So this is the carrot, it's not really the prize. Then there is a final evaluation phase, which is handled by human reviewers. We provide 20 Tesla T4 GPUs with 16 gigabytes of RAM to run your submissions, and you have 2 hours per submission. And now, some more explanations about the challenge workflow. So I told you that you can submit AI agents that can be either or both AI authors or AI reviewers. So this is how they're going to be evaluated. When you submit an AI author, here we go, it gets swallowed by an ingestion program that takes some prompts and submits it. So you remember that this is code submission. So what's happening here is invisible to the participants. The ingestion program takes the prompt and your program, and then your program is generating papers. And then our AI referee reviewer is going to review the paper, compare it to good and bad ground truth papers corresponding to the prompts, and then outputting a review. And then the score of the review is going to appear on the leaderboard, and actually you're also going to get explanations about the review, like real review, textual explanations why you got that score. Now, if you enter the AI reviewer track, and you can enter both, right? You submit an AI agent that can be capable of both. But in the AI reviewer track, your reviewer is going to be reviewed using the good and bad papers. And the meta reviewer is going to check whether the good papers are ranked higher than the bad papers with respect to a number of criteria. And the meta reviewer is also going to output meta reviews in text to explain the decisions made. And this is going to appear, on the leaderboard. So this takes place both during the feedback phase and the development phase, where you get this automated evaluation that we also call auto-eval. Questions about that? I have really good students here who ask questions.
So one thing I was trying to figure out is, I guess when, let's say I'm interested in developing an AI author, then I might have some prompts that I generate myself. I might have some good or bad papers that I pick for myself for that prompt. And then so I can loop through this and see how my AI author is doing. So that would be the training phase of my author. At test time, does my AI author know the prompt? In other words, is it visible to me, or is that part of the black box of evaluation? Meaning I never know what prompt my AI author was evaluated on.
So yes, that's a very good question. So ideally, we would want to have a blind test in which the participants never know about the prompts.
Yeah.
Practically, because we allow access to the internet, we can't prevent, your agent to send the prompts, and you could, eavesdrop on the prompts when your code is evaluated.
I see. Okay. No, at the very least, I'm thinking that the prompts may not be known to me ahead of time when I'm building my AI author.
Yes, we are trying our best to do that. So, for example, in the development phase, we are every time you're submitting a new entry, we're picking up 5 prompts at random in a pool of 80. So you get fresh prompts every time.
And is there a track 3 where you evaluate those who submit an ingestion program, a author and a reviewer, or pairs of author reviewer submissions from the community rather than your default reviewer? Meaning what I'm thinking.
So in the final phase, we are going to run all the authors against all the reviewers.
Got it. Yeah, that's what I was asking.
That's what we're going to do. Yeah, we thought of doing it during the development phase, but this would have created instabilities and would have been very complicated. Right. So yeah, that's why in the development phase we only use our referee reviewer. But in the final phase, we like this idea of basically emulating this peer-reviewed journal and having the reviewers review, the.
No, but it also goes back to John's question, namely this might create a real black box where I have my own author, my own reviewer. I have no idea what they do. They just produce a good paper in the end.
Yes. You're welcome, to have an internal loop if you want to, but you have this 2-hour time limit for running your submission.
Yeah.
Okay, so, and in the final phase, the humans will be reviewing the papers of the AI authors, and the scores will be used, for ranking the participants. And for the AI reviewers, the reviews that have been made of the papers generated by the participants will be compared. So the AI reviews will be compared with the human reviews. So by having, humans review the papers generated by the agents of the participants, we do 2 things. We rank the authors, but we also rank the reviewers because we can compare their reviews with the human reviews. And then we're going to use some kind of, correlation coefficient between ranks that are used in essay scoring, either the Kandel-Tau or the Cohen-Kappa or both. And so now I'm going to get into what kind of data we had to provide as organizers. So first we had to provide prompts, and I had already questions about what these prompts are going to be. I'm going to explain that. And then we had to provide this AI referee reviewer, the AI meta reviewer, and for those we had to give review instructions. And we also needed to collect good and bad papers that are kind of the ground truth for the prompts that we gave. So first, the method of prompt generation. So it's actually difficult to generate good prompts, but language models are good at it. So we use language models to help us with that. So a typical prompt would be write a systematic survey or overview about the application of machine learning in healthcare. In order to obtain such a prompt, what we can simply do is to take an actual human survey paper and ask a language model, generate a prompt to be input into a large language model, into large language models, starting with write a systematic review or overview about, and then we give the title and abstract of the paper. So we had to do a little bit, of prompt engineering so that the language models generate actual, good prompts, like, tell it, limit yourself to 2 sentences or things like that. But with such a simple method, we could generate a lot of prompts, and then we had them reviewed by humans. So we obtained 600 prompts, and after manual review and elimination, of prompts that were either too trivial or too specialized, we selected 80 prompts that we are using in the challenge. Is that clear? Then the AI reviewer instructions. So in order to get that, well, we went over the instructions that are provided to conferences and journals and tried to find kind of a small number of generic review criteria. And so we homed on using Relevance, which evaluates whether the paper responds well to the prompt. Contribution, which evaluates how impactful the paper is in terms of novelty and significance in general. But for survey papers, this is more, whether the paper provides a comprehensive overview, contrasting and comparing a plurality of viewpoints. For soundness, usually, for a general paper, we would evaluate the scientific correctness of the claims made in the paper. But for a survey paper, the soundness means more whether the paper provides accurate facts supported by correct citations coming from authoritative references. Then clarity evaluates whether the paper is written in good English with correct grammar, precise vocabulary. Also means that the paper is well organized with meaningful sections and subsections, and that the concepts are clearly explained with short sentences. Responsibility evaluates whether the paper addresses well potential risks or ethical issues and is respectful of human moral values, including fairness and privacy. So finally, we have an overall criterion that captures the overall recommendation of the reviewer, and a confidence, which captures the confidence of the reviewer. So we implemented an ad hoc referee reviewer that's based on this criteria, and we normalized the scores between 0 and 1, with 1 is best. So what we have not implemented yet actually is the confidence criterion so far. Right. And as I mentioned before, the AI reviewers are also asked to provide textual explanations of their scores. Questions about the criteria?
So lots of review forms have a confidence question in there, but in my humble opinion, it's a useless question. There's no information in it as far as I can tell.
Yeah, that's partially why we didn't implement it and give up on it. So we have doubts this is highly useful. On the other hand, it's scientifically interesting. Because there's a lot of research that goes into having machine learning models output their confidence. So we might get into it at some point, but yeah, for the moment we're skipping it. So yes, now let's get into the generation of the good and the bad papers responding to the prompt. So you remember that the prompts that we have were generated from actual human papers. So we have, in fact, the pair of the prompt and the human paper that corresponds to it. We could use the actual human paper as kind of ground truth, but it's not in the same format as the papers that we asked the participants to generate, because we asked the participants to generate short surveys of about 2,000 words. So the first thing we did is that we asked the language model to paraphrase the original human paper and put it into the format of the challenge. And that's our good, ground truth paper. And then we asked also a language model to paraphrase the original human paper, but turn it into a bad version with respect to some of the review criteria. For example, we would ask, to rewrite the text with long and winding sentences and write it in very poor English to have the ground truth for a bad paper with respect to clarity. And to have a ground truth for a bad paper with respect to contribution, we would say, to to write a very bad conclusion, for example. Or for responsibility, we would ask, to rewrite the text as a political argument in a polemic style, which is inappropriate for a scientific paper. So, we have mixed results. Sometimes, the bad generated papers are really meaningfully bad. Sometimes they are not that great, but that's the best we could do in the short amount of time that we had. This requires more work, obviously. But I think this basic technology, is promising. So here is an example, for example, of good and bad paraphrase paper. With respect to English. So the good one has a title, The Role of Artificial Intelligence in Microscopy, a Comprehensive Guide, and the bad corresponding title would be Machine Think for Tiny Luxie, Think you Need Know. I mean, don't ask me how it came up with something that bad, but we did some prompt engineering. And so for the deep learning, a subset of artificial intelligence is paving the way for remarkable advancement in the field of biomedical research, particularly with its potential to transform microscopy. That's turned into machine think with deep learn, start new path in life study research, promise big challenge for tiny Luxie field. So that one obviously would look outright very bad, but sometimes it's slightly more subtle than that. I just wanted to give you an extreme example. So now what are the methods that were put together by the organizers? So I'm going to talk now about the baseline author, the AI referee reviewer, and the AI meta reviewer that we implement. For the baseline AI author that we actually provide to the participants as a sample submission, we just asking ChatGPT to write a systematic survey or overview about the particular topic and return the result in JSON format, which facilitates the work for our reviewer afterwards. In particular, it's then going to be organized in subsections and highlight the bibliography. For the AI referee reviewer, so all the criteria that we talked about before were implemented in some way, mostly using third-party software. For relevance, we are looking at we are comparing the paper title and the prompt using some embedding. So are they close to one another? Also, same kind of method for comparing paper abstract and prompt. And then we are comparing citation titles and prompt also with a similar method. For contribution, we are now comparing the abstract with the paper. So basically the question would be, does the paper deliver on the abstract? We're also comparing the conclusion and the paper. So the question being, does the paper, does the conclusion, capture well the information that's in the paper and provide interesting insight or something like that. And then we do the same thing also for let's see, for the citations. We'll look at whether the citations cover well the field. And here, as you will see in the results, we're not doing a very good job yet with the citations. So my big hope is that you guys are going to contribute to help us improve on verifying that the citations really cover well the topic. Then soundness, we're simply verifying that the citations exist and that they align well with the paper in terms of contents and that they are diverse. So the difference with relevance is that in the relevance, we verify that the citations align well with the prompt, whereas here we verified that the citations correspond well to what is claimed in the text. Then for clarity, we're using some features that we found in the literature and also some Kaggle essay features. This domain is quite well studied already because essay scoring is a big business. So we basically rely, on previous work. For responsibility, judging, the moral value of a paper is tremendously hard. So at this stage, we don't do it. We're only running Perspective API that checks for the toxicity of the paper. Now the meta reviewer. So the task of the meta reviewer is going to check whether the AI reviewers are doing a good job or not during the feedback and development phase. So automatically evaluates the reviewers. So what the meta reviewer is doing is that it's taking the good and bad papers and is verifying whether the reviewers are ranking higher the good papers than the bad papers. So that's a first way in which we do it, which we call contrastive evaluation. Right, so then we generate an overall score that is the average for all the subscores, the results of the meta reviewer for all the subscores, relevance, contribution, etc. And then we run about, we run the whole thing for a number of sets. What we call a set is a number of good and bad papers that have been generated for a particular prompt. So we have like 80 prompts, as I said before. So it's actually quite a large number of good and bad papers. So the meta reviewer is pretty solid with respect to that. Then a second way of doing meta review is using meta review criteria. So what we do here is that we take the review criteria, and for each review criterion, we have a large language model evaluate the review that was done, the text of the review, and whether the text of the review is consistent with the score with respect to a number of meta review criteria that I'm highlighting here. So in the end, what we get is a big matrix with review criteria in lines and meta review criteria in columns, and we have a score for each value in this cross product, and then we average all the scores, and this gives us a second rating. So basically, for meta review, we have two ratings. The first one comes, just by contrastive evaluation, and is based only on the scores of the reviewers. And the second method uses the text of the reviews and uses a large language model to analyze the text of the reviews. And then we average both scores. All right, now some preliminary results, but before that, are there any questions?
Hi, thank you. So for the reviewers, how do you select them? And then in terms of the text that you will evaluate, how much text do they need to, I'm sure that you will not allow just one line in order for you to do the scoring.
Well, that's a good point, and I actually don't have the answer for that.
Oh. Okay.
I don't know. I don't recall whether we give a maximum number of words for the reviews. But if we didn't, we should. You're right. Yeah, I think we based ourselves on the fact that our baseline reviewer, which is based on ChatGPT, never gives very long answers, but we never know. Yeah, but I guess in that case, if it gave too long answers, then we would go over time for the evaluation, and it would take more than 2 hours, and then. But it's a good point. We need to introduce that. Yeah, thank you. All right, other questions? Okay, then let's go into the preliminary results we have. I will talk to you about how we evaluated our AI referee reviewer, and then how we evaluated our AI meta reviewer. So for the AI referee reviewer, we used the good and the bad papers. And on this chart, each red dot represents a pair good-bad paper for a particular criterion. So recall that when we generated the bad papers, we generated them to be bad with respect to a particular review criterion. So in each of the columns, you have actually different bad papers. And then what we plot is actually the difference in the score between the good and the bad papers. The scores are normalized, so everything is between -1 and 1. And if you're above 0, it means that the good paper is better than the bad paper. And we use a box plot where the red line represents the median value. The top and the bottom of the bar are the quartiles, and the whiskers are the 10 and the 90th percentile. And the dots, represent the distribution of the pairs of good, bad papers with respect to the difference of score. The displacement in X is meaningless. It's just meant to facilitate the visualization so that we, see the distribution of red dots, which is unidimensional along the y-axis, easier to understand. And so what we see here is that, at least in this version, it keeps changing and improving. The soundness is pretty good. So the soundness, what is it? So it's about verifying that the citations are correct. So in that case, the good papers were generated in the following way. We asked a language model to take the human paper and paraphrase it. And for the citations, we treated them separately. We asked the language model to select the 10 most prominent citations of the human paper. So not so surprisingly, the citations are real citations most of the time, even though humans sometimes maybe make up citations, but most of the time they are correct citations. Whereas the bad papers, well, these are mostly made up citations by a large language model, which just told the large language model to figure out some citations, and they usually hallucinate them. So the soundness shows a big difference between the good and the bad papers. I would guess the second best is the responsibility. Here, this is just the result of Prospective API, this third-party software that checks for toxicity. You saw how we generated the bad papers. We really told, the language model to write something that's very polemic and completely inappropriate as a scientific paper. So it wrote very bad language, and so the difference is significant. For the next best one, I think, is clarity. You see also that there is quite a bit of difference between the good and the bad papers with respect to clarity, but you also have a much bigger spread. Sometimes, it's not as easy to detect that a paper is good or bad with respect to clarity. Then afterwards, we have contribution and relevance. And not so surprisingly, these are the hardest to diagnose, because this is now really about the contents of the paper. So for contribution, we're looking at whether the references cover well the field, in terms of a survey. Is it, really capturing well an overview of the field, and whether the papers are cited appropriately in the text, and that kind of thing. So that's harder to determine. And for relevance, we are looking at whether the papers cited really respond well to the prompt. We're also taking into account in contribution the diversity of the citations. And now on this chart, we are measuring something slightly different. Now we are looking at papers that are generated by our baseline AI author, which is ChatGPT. These are the blue bars. And we are comparing it with another baseline, which we call dummy, which is just generating, which is picking up a paper at random among human papers, but not related to the prompt. So with very bad relevance. And actually, not surprisingly, you can see that with this scheme, ChatGPT creates papers that are pretty relevant. but the human papers are irrelevant because they don't correspond to the prompt. With clarity, on the other hand, they are a little bit about on par. For contribution, ChatGPT is seemingly a little bit better. We are going to look at it more closely because there are sub-criteria at the bottom that we will be analyzing. For soundness, interestingly, the human papers seem to be a bit better, but it's not so surprising because soundness is checking whether the citations are correct. And for responsibility, it's about on par. So now if we look a little bit more closely at the sub-criteria, for relevance, we're looking at whether the title is aligned with the prompt, whether the abstract is aligned with the prompt, and whether the citations are aligned with the prompt. Well, it's not surprising to see that ChatGPT is better aligned because, as I said, we chose the human papers to not match the prompt. We took random papers not related to the prompt. So in this way, we can check that our relevance criterion works well. For clarity, we're looking at 3 sub-criteria: organization, explanation, and language. We're not expecting that they should, be that much different. We do see, that there's a little bit of variance, but there's no significant difference if we look at the error bar. And for contribution, there we see the question is whether the abstract delivers on the text. So the abstract summarizes well the text. So what we find interesting is that ChatGPT thinks that its own abstracts are really good, for the paper it generated. Which is one of the questions that was asked before. Maybe we should run, the AI reviewer against other AI authors, because a particular reviewer reviewing its own paper is usually very lenient. And we see the same thing for the conclusion. ChatGPT is very happy about its conclusion. The coverage is not very good at all for either. So what the coverage is that it's checking whether the citations that are made overlap with the citations of the original human paper that is supposed to be the ground truth for the survey. So there we need, to put in more work here. There could be a number of reasons why this is so bad. One of them is maybe the bibliography of the humans are not good. Maybe it's not up to date. Maybe there is such a huge bibliography anyways that you could have a 0 overlap and still have a pretty good survey paper, etc., etc. So we need to analyze that and come up with something better. And then for soundness, soundness is about whether the paper exists in the literature or not. Is it a hallucinated citation or not? Well, we see that ChatGPT hallucinates citations quite a bit, which we knew already. Alignment, whether the cited paper is the text of the cited paper. Here we only check the abstract. The abstract of the cited paper corresponds to the abstract of the original paper. And yeah, it's not very good, but it's about the same for both. And then the diversity, whether the bibliography is diverse, and here we have about the same. So this is what we get, for testing our AI referee reviewer. Again, it's work in progress. We're hoping to improve on that in the future. And we did a sanity check of our meta reviewers. So for that purpose, we implemented various baseline reviewers other than our own AI referee reviewer. One of the baselines is just random scores and random text. And one of them is a large language model that generates the scores and the text justification of the scores, which is actually our baseline. What's going on here? No, It's stuck. Yeah, but it's stuck. Come back. These are the results of the evaluation of the meta reviewer. Each bar represents one of the models. So the model I is the random. The model B is the large language model that performs review and provides scores and text. And the model 6 is our baseline, is our referee reviewer. So our referee reviewer performs quite a bit better in general, except on soundness, where we have pretty bad results in general. But yeah, we need to improve on that. And again, it's the problem of the citations. And here what we see, is the fraction of good papers that are classified higher than bad papers. And generally, we're doing quite well with our referee reviewer. But can I get to the next slide, please? I must have badly messed up. Okay, cool, thank you. Oops. Okay, great. Fine. And so in conclusion, we designed an end-to-end competition for peer-reviewed survey papers and implemented preliminary AI author, AI reviewer, and meta reviewer. We believe this notion of an AI meta reviewer is novel, at least in this context. We implemented sanity checks for both tracks, and further work include improving our AI author baseline with respect to citations particularly, improving our AI reviewer, and with respect to coverage particularly also, which also involves citations. We need to further evaluate and improve the meta reviewer, in particular evaluate the large language model meta review. And last but not least, please join the challenge. Here is the URL. And there will be this afternoon a tutorial where I can guide you step by step on how to make submissions and guide you towards, give you some tips so that you can eventually win. So maybe or somebody else can tell me where the tutorial will be and when.
If the room is okay here, we can have it here. Otherwise, we can have it in the room where we'll have lunch also. So it's a flat room, or here if you prefer. What?
Yes, I think this room can work. I have some slides, so maybe that's good to be in this room. It's not as convivial, but we'll make it work.
Okay.
At what time? Just right after lunch?
It's up to you. Yes, we can have it. I think 1:30 or 2. 1:30.
So raise your hand if 1:30 is not good for you and you would like to come. Raise your hand if 1:30 is good for you. There are tentative hands. Yeah, not so many people, maybe. So there's another possibility that you can also during lunch come and ask me questions, and I can already give you tips during lunch if you don't have time to come afterwards for the tutorial. Or I can, make myself also asynchronously available during the whole afternoon because I only leave at 5. So you can book time with me, basically, if you want any time in the afternoon, if it's more convenient in this way. More questions. Everybody's hungry.
I was just wondering about the multilingual aspect. If you I mean, I'm assuming this is all in English, but if you did it in French, would it read and translate English papers, and how might all that work?
Yes, so as I explained at the very beginning, I'm not at all a language expert. So yeah, we did limit ourselves to English. I should have said that at the beginning. In the future, we possibly will first extend to multimedia and ask for having figures and graphs, because I think it's hugely important. Right now, at least in the scientific literature, there's a large body of English papers, which also is a motivation for keeping English for the moment. We are not limiting ourselves to just foundational sciences, right? To math, physics, computer science. You've seen that we have social sciences as well, and art and history, geography, etc. So in that respect, we're quite broad. But in terms of going multilingual, I think it's going to be next step, right? So it's not our immediate concern.
I had a question regarding some of the future steps. So I was thinking about how to get an AI author to sort of have the right citations, and also to a lesser extent coverage of the material that your reference paper had, right? So these AI authors are being built today, and those reference papers might be 10, 20 years old. I don't know how old they are. So two things are possible. One is that indeed the coverage is bad because it's muddied by all these newer papers that the AI author could cite. But the other possibility is that the AI author is actually citing relevant papers. They just don't match your criterion because your reference paper was old.
No, but very admittedly, we did a very preliminary job on that, because we wanted to have the end-to-end system, and each of these criteria is a research topic in itself. We wish we could just plug in a better module. Maybe if you can point to us a third-party module that we could plug in, that'd be terrific. And obviously, well, already by entering the challenge, you can win on that part, because it's easy to improve on it. During the feedback phase, we were open also to suggestions of how to make changes. At this stage, maybe we don't want to make that big changes, but this is just the first, competition of a series. So this is another way in which you can, engage, is that you can come to me and say, oh, gee, I'd like to be co-organizer of the next version. and I have plenty of ideas how to make this better. We are welcoming new collaborations.
So I have a kind of nightmare, maybe I'm kind of paranoid or something, but I'm worried that somebody might write a journal article after the next NeurUps thing that says that, you know what, somebody's bot is so good that we don't need no stinking scientists anymore, and that they've just solved all the world's problems. And there's a lot of papers out there that sort of say that the AI is better than human translators at blah, blah, and blah, blah. And the AI is better than we are at transcription. It's better than everything we could imagine doing. And a lot of people believe these results. So I'm kind of worried about the reliability and the validity of your test, that the test looks pretty reasonable, but imagine there's some ways to do really horrible things that you probably don't dock that much points for. So like you called it soundness and it's just averaged in with other things. But if you plagiarize, or if I make up data, or if I hallucinate, these are things for which you would get fired for, all right? Not just now, but ever in the future. So, presidents of universities are being fired because people in their lab cheated. This is not something that I just average together with, good English. These are fatal errors. We need to worry about the reliability and the validity of this test, and make sure that someone doesn't report that my bot that just makes stuff up is better than all the scientists.
Yeah, no, I completely agree with that. In particular, this problem of fatal errors versus, averaging. I was myself once, a program chair of a big conference, and I was fighting against just averaging criteria for that reason. And we had a number of criteria that were fatal, like, if there is, a fatal flaw in a proof, paper's rejected, regardless of whether it's written in great English. It doesn't matter, it doesn't average out. So we ended up doing a little bit of that already now. We singled out the relevance, and in fact we average all the criteria and then we multiply by relevance, because if it's not relevant, it's out. But there are other criteria that can be fatal flaws as well.
Question, maybe a remark. Have you tried to use the Wolfram Alpha plugin in the ChatGPT for any of these? Because the ChatGPT and any GPT is notoriously known for hallucinating stuff, especially numbers, while implementing, and Wolfram Alpha already published a plugin into ChatGPT where there is a layer which translates your prompt, injects it into Wolfram Alpha, then it's interpreted, getting the relevant sources, injecting back and retranslating it into a language that is human understandable. So you actually get proper graphs, you get proper references. So that one would actually, as AI author, would probably be better, but even better for the reviewer, because it would actually get the proper known references for the reviewing.
Yeah, no, to my knowledge, we didn't get into that level of sophistication. We were, too busy just getting the end-to-end challenge working. Well, I don't know. Either we should do it or we should let the participants do it and try to win.
It's going to be difficult to compete with Wolfram Alpha, I believe.
Well, then try it and win.
No, I just wanted to say that we have the candidate for the winner for the challenge.
Yeah.
Yes, Wolfram.
Yeah, let's encourage him.
Yes.
So, thank you. I have a question. Do you think there is a way to know on certain parts of the submission, the survey, if the model is confident or not? My point is to ask the human author behind the model to provide a final decision in case of the model not knowing exactly if the answer is correct or not.
Yes. As I said at the beginning, we had, confidence was one of the criteria, but we didn't implement it yet. There are many ways in which you can evaluate confidence. The easiest is to do some kind of bootstrap or repeat, the production of score and look at the variance. But of course, that only captures the statistical variance and not bias. So it's a difficult and open question that I think deserves more research. And we welcome, anybody who wants to work on it. There's one more question. Too late.